So today we're going to finish up the notes on section 2. So again, we're still using the same Pythagorean identities and the same quotient identities, the same reciprocal identities in order to simplify each one of these trig equations. Okay, so let's go ahead and get to the examples. We did all of these all the way up to number 12. This is where we left off. So for this first one, I'm going to go ahead and simplify the left side. And I'm going to make it equal the right side. So again, we don't want to use inverse operations. We don't want to try to touch both sides. We want to try to only touch one side and make it equal the other. So what I'm going to use here is whenever I see something being added and subtracted, I always try to think, I got to add these. I got to find a common denominator. So I'm going to go ahead and first change these into sines and cosines because that's one of the strategies. So I'm going to change tangent into its quotient identity and make it sine x over cosine x. And then I'm going to change cotangent into cosine x over sine x. Now, remember, the Pythagorean identities have squares in them. Tangent of x, I can't use a Pythagorean identity because there's no square there. So just be careful whenever it doesn't have the square, you can't use a Pythagorean identity. So this one I'm just using my quotient identity. Now what I'm going to do is add these two fractions. My common denominator is going to be both sine and cosine. So it's going to be sine x times cosine x is going to be the common denominator that I'm going to get for both. Here's my fraction bar, and it's not really showing up. Maybe I'll do yellow. And now for the first fraction, what I'm missing, what I need to add in here is it's missing the sine x. So that's what I'm going to multiply to the top and the bottom. So then this becomes sine x times sine x, which is just going to be sine squared x. Then the other one is missing the cosine. So when I multiply cosine over here to the top and the bottom, this becomes cosine squared x when I multiply that numerator. Now that I have a common denominator, I can add the numerators. So now this becomes sine squared x plus cosine squared x, and then it has the same denominator still, the sine x, cosine x. Notice the numerator is that Pythagorean identity. Sine squared x plus cosine squared x equals 1. So that's what I'm going to replace the top with. So this is going to equal 1 over sine x cosine x. And now remember, we're trying to make it equal secant and cosecant. Well, what we can do is realize that this right here, 1 over sine x is going to be cosecant, and then 1 over cosine is secant. So now this simplifies, and I know I've run out of room, but this will become cosecant x, secant x. And again, multiplication is commutative, so I can just flip it around and make it secant x, cosecant x, and that's what it was trying to make it equal, because that's what this side had. Then for number 13, I'm going to simplify the left side. It is more complicated than the right. I'm going to change the secant and the cotangent into sines and cosines. So I'm going to use the quotient identity for cotangent and the reciprocal identity for secant. Again, I can't use the Pythagorean identity here. There's no square. So I'm going to change cotangent into its quotient, which is cosine over sine. And then I'm going to change secant into its reciprocal, 1 over cosine. Notice when I'm multiplying here, I can simplify the cosine x's. They become 1s. And now I'm left with 1 over the sine x. And the reciprocal to sine is cosecant. And that's what it was asking me to make it equal. So it's done. For number 14, again, I'm going to simplify the left side. It's more complicated because it's got a subtraction sign. So what I'm going to do is change again everything into sines and cosines. So I'm going to change cosecant into its reciprocal, 1 over the sine of x minus the sine of x. I'm now going to find a common denominator. My common denominator is going to be sine x. This one's missing it. So I'm going to multiply top and bottom by sine x. So now I have 1 over sine x minus sine squared x over sine x. I now can add the numerator, 1 minus sine squared x over sine x. Now what I'm going to do is replace the numerator with a Pythagorean identity. 1 minus sine squared x is equal to cosine squared x. Now what I'm going to do is pull this apart. I'm going to factor the top. The top becomes cosine x times cosine x. And then I could put a sine x under this one. Actually, let's put it the way it wanted. I'll put a 1 there. And then put the sine x under this one. And then this one just stays cosine x. And then this one, I'm going to use my quotient identity, and it becomes cotangent. And that's what was on the right side. So cosine x, cotangent x. And we're done. Now, this next one, I could do this either way. I could try to simplify the addition and make it look like the right, or I could simplify the fraction and make it look like the addition problem. Let me do the fraction instead on this one. So what I'm going to do here, just so we can get a variety, I'm going to go ahead and multiply. I'm going to simplify the right side, and I'm going to multiply it by its conjugate. So I'm going to take the right side, and the conjugate is going to be 1 plus sine x. So once I multiply this, the numerator is going to just become cosine x times 1 plus sine x. The denominator, I got a FOIL, becomes 1 minus sine squared x. Notice I didn't distribute it, because what I'm going to do is I'm going to change the denominator. It's a Pythagorean identity, and I'm going to replace this with cosine squared x. Because remember, sine squared x plus cosine squared x equals 1. So that one was manipulated and rearranged. So now in the numerator, I still have this. Now I can simplify. I can cancel the cosine here and take away the power there. Now I have 1 plus sine x left in the top over cosine x. Now what I'm going to do is think backwards of what it looked like before I give each one its own denominator. So I'm going to split this up, and I could put 1 over cosine x plus sine x over cosine x. So what I did was I took each one of these and gave it its own denominator of cosine. Because if I were to add this, it goes back to that. Now that it's split apart, now it looks like what it wanted me to simplify it to. Because 1 over cosine x is secant x. And then this one, sine x over cosine x, is tangent x. And it had a plus sign in between. And that's what we had on the left side. Let's do a couple more examples. So here, now, at the beginning of class, somebody had asked me, can you simplify both sides? You really shouldn't, but if you can maybe simplify it maybe in one step, but you really shouldn't be working on both sides of the equation. But let me go ahead and just work with the left side still. So what I'm going to do is, this is a Pythagorean identity, the top. So just to review it, this one is 1 plus cotangent squared x equals cosecant squared x. If I move the 1 over, cotangent squared x equals cosecant squared x minus 1. That's what I'm going to substitute here. So this will become cosecant squared x minus 1 over 1 plus cosecant of x. Now the denominator is not a Pythagorean identity because it doesn't have a square there. What I'm going to do now is factor the top. The top will actually factor into cosecant x minus 1, cosecant x plus 1. Denominator still has the same. And got 1 plus this way. Now remember, addition is also commutative. So these two that are right here are the same. And now I'm left with cosecant x minus 1. Now, what I can do to make it look like the other side is I can now change this into its reciprocal, 1 over sine x minus 1 over 1. And then what I need to do is find a common denominator. And this would be, let me do it over here, 1 over sine x, and then sine x over sine x. And then now go back and add it. And now it looks like this side. So again, there's always ways to rearrange it so you don't have to touch the other side. Let's try the next one. Again, I'm going to use a Pythagorean identity. For the numerator, I'm going to do the left side. This looks just like the other one. So again, the Pythagorean identity I'm using is tangent squared x plus 1 equals secant squared x. And I'm going to go ahead and move the 1. So tangent squared x equals secant squared x minus 1. This is what I'm replacing for the tangent squared x. So I'm going to get secant squared x minus 1 over 1 plus secant x. Just like the other question, I got to factor it. So the numerator will factor into secant x minus 1, secant x plus 1. And then it still has the same bottom. And again, remember, addition is commutative, so these two cancel. So now I'm left with secant x minus 1. And just like before, we'll change secant into its reciprocal. -1. Find the common denominator. So really what I'm doing here is multiplying that 1 over 1 and making it cosine over cosine. So 1 over cosine minus cosine x over cosine x. And then add them, 1 minus cosine x over cosine x. And that's what was on the right side. So 1 minus cosine x over cosine x. It verified, it checked. Two more and we're done. So for this one, what I'm going to do is simplify the right side. I'm going to factor out a GCF. My GCF is going to be tangent squared x. Once I divide it, I'm left with secant squared x minus 1. Remember, up here, tangent squared x is equal to secant squared x minus 1. So that's what I'm going to substitute. I'm going to plug in tangent squared x. So I'm going to substitute this for tangent squared x. And now I just multiply. Remember, when you multiply something with an exponent, you just add them. So it becomes tangent to the 4th x, which is what it wanted you to get to. It verified. Going to do the same thing on the other side, something similar here. Let me go ahead and do this left side on this one. So over here, I'm going to replace, I'm going to pull this apart and I'm going to factor it. So cosecant squared x times cosecant squared x times cotangent x. I am going to replace, this one's a little different, this with the Pythagorean identity. So if you notice the one up at the top, this one, this is the one I'm going to use. So I'm going to replace cosecant with 1 plus cotangent squared x. So I have cosecant squared x, and then I'm going to replace this with 1 plus cotangent x. And then times it by the cotangent still. Now what I'm going to do is distribute this in here. So cosecant squared cotangent x plus cotangent cubed x. And that's what they wanted me to get to. I just have to, oh no, that's what it has. So then this is the same as this, so I'm done. The other side was probably just as complicated. You could have probably simplified that one to make it look like the left. Again, there's always multiple ways to verify these things, just as long as everything makes sense. So that is it for the notes on 7-2.